Hello everyone, welcome on this video. And in this video lecture we will be studying the motion under gravity. This is a very special type of motion, particular motion, and that is taking place in the influence of gravity. So what is the gravity? Let me give you an idea. The earth on which we people live, it appears for us as a flat. So if we are here, let's say that's a person, observer we can call it, and then in this space or that atmosphere, a gravitational force acts downside on all the objects, whatever the objects we think about. And that gravitational force you might have understood or heard earlier is called m into g. In a gravitational chapter we will see how this force is coming, but for the time being we can think of it as m into g, where m is the mass of the object which is moving. And we also know this force is also equal to m into a, and if we compare these two, then we can find a is equal to g. Now F equal to ma is basically equation in which we use the net force. So this is a net force, and this is the force due to gravity. So if we can say, if the object is experiencing only this force, gravitational force, then we can claim that acceleration of the object is going to be given by g. And this is pointing downwards. So if this is earth or surface, then you'll find there is acceleration acting downside, and that is known by g, small g. That's called gravity or gravitational constant. And this g value is 9.81 to be precise, and it comes out to be meter per second square because acceleration, but we are going to take it in general as 10 meter per second square, so that our calculation remains easier. Right. So in examination we will be using 10 meter per second square to find our answer, until and unless it is given as a 9.81. And if the answer is not exactly coming, then we can think of this 10 has been used in place of 9.81. Why I'm saying this, using this, that will save your time and make your quick calculations. And if you want to use this, you can always do that, and that's going to be giving you more precise answer. Anyway, so that means this acceleration already exists in the atmosphere for all objects, and this acceleration is independent of the mass of the object, right? So if any object is released in this or thrown in this atmosphere, then you'll find this is going to experience this acceleration. So because of this acceleration, the path of this object will be decided, or you can say, depending upon this, whether it has been released or being thrown, it can move in one-dimensional or two-dimensional. So whatever I am showing over here, that's object, and whatever I have drawn over here, that's observer. So when we explain this or describe the kinematics, we need to have an object, we need to have an observer, and we need to see this object over the time. So if you look at over the time, it can move in the vertical direction, upside, downside, or maybe in some curved path. So there are two types of path or motion are possible. So we are going to talk about both these motions one by one. So now here we can define what this motion under the gravity is. We can say this is a particular type of motion. That means we can write over here a motion. Let me write it this way: a motion that takes place under the influence of gravity alone. So if it is under the influence of gravity alone, then we call this motion under gravity. That means it's basically trying to say this is a motion having a given acceleration, which is g, and g is a number which is 9.81, or you can call it as a 10. Now this motion under the gravity is of two types. One is going to be vertical motion or one-dimensional motion. Two types of motions are there. That's called 1D motion in one dimension, which is also known as vertical motion. And in vertical it can go upside, downside, both. And the second is going to be two-dimensional motion or plane motion. This is also called plane motion. Which is also known as projectile motion. So we will talk about this projectile in detail. So one by one we will be covering both these types, 1D motion or 2D motion or whatever. Now one thing is clear, that this that acceleration is a constant. Since acceleration is a constant, then our equations are going to be of constant acceleration case. So for all the motions under the gravity, we can have equations of motion like this. Equations of motion. We have already talked about equation of motion for constant acceleration case and for variable acceleration case. Here we are going to use the constant acceleration case. So our acceleration is constant. And if we want to plot or design coordinate system, we can design this is x, this is y, and z is outside. So let's say this xy plane we are talking about. So acceleration will become g as a magnitude minus j cap as a direction, meter per second square. Idea is that this is a constant. It is a constant in both magnitude as well as in direction. That means neither its magnitude changes nor its direction changes. If the initial velocity of the particle is given to us, so first equation will be v is equal to u plus ad, a vector into t. It will cover one-dimensional motion as well as two-dimensional motion. And what we need to do, we need to substitute a by minus j cap. That's all. And similarly, displacement, we can talk. Displacement of the particle is going to be is equal to ut plus half at square, where a we know and u will be given to you because u is the initial velocity. So initial velocity also influence the other parameters. And then we can write this third, which is v vector dot v vector is equal to u vector dot u vector plus 2 times a vector dot r vector. R is a displacement vector. Similarly, we can also write the fourth one, the displacement covered during nth second. So these are going to be equations of motion for the vertical motion or two-dimensional motion, or we can directly say is motion under the gravity. Now we will be learning in this particular video the uses of these or applications of these equations. So let's go ahead and talk one by one. So number one is this vertical motion. Now in this vertical motion, particle is going to move only in two directions. Either it will be moving upwards or downwards. So that's going to be one-dimensional motion. That means path will be straight line. The case may be particle is moving upside, or the case may be particle is moving downside. Either of the cases may be. And this is the ground, so we need to make where the earth is. And we will keep our observer on the earth, so that means we are watching everything with respect to earth. So here we will be saying that this is going to be basically 1D motion. So that's a one-dimensional motion. Whenever this is one-dimensional motion, so we can remove that symbol of arrow, that's a vector, and we can write simply numbers and carrying the directions. So what we need to do, first of all, we need to decide the coordinates, directions. Until and unless anything is specified, so we will be assuming this as our coordinate system. So you can choose any other coordinates, these directions as a x and y, choice is yours. When we choose this, that means we consider this direction as a positive x, this direction as a positive y. Here our focus is with the y-axis alone. So this y will be positive in the upward direction and y will be negative in the downward direction. So if somebody is going downside, so that means y is to be measured as a negative. Downside means downwards basically, and it can be here as well. So let's say talk about this arrow. This is pointing downside, so we will write its velocity as a negative. This is pointing upside, so its velocity will be written as a positive. So direction will decide, and we need to consider the origin. So we can consider our origin on the ground, or we can consider our origin over here, because origin is the reference from where we measure upside and downside. Making sense or not? So if we are using this, then we can say if our object is, let's say, located at any particular location here, and we have taken, let's say, our reference origin at this point from where it has been thrown, so that's our origin. So, and let's say at this particular instant the object is moving like this. So what are going to be the ways to write its parameters? So we will say that this is going to be represent the position of the object. Position means displacement from the origin, and since it is in the upward direction, so we will call it as a h. Let's call it as a h, or we can call it as a y, because that's a y coordinate. And if it is moving upside with velocity v, so it's going to be v. And we know there is a acceleration that keeps on acting downside always. So these are the parameters we need to write in our equation. First the position, another velocity, another gravity, that's acceleration, and time. So you can say our equations will be like this. First equation, if you write, is going to be v is equal to u plus at. That's our equation. Now you will depend from where you have thrown the object. If the object has been thrown, let's say, from this point, so that will be the initial velocity u. And then you'll find we can write the equation for this particular case. So basically I have considered a case in which a particle is being thrown from the ground in the upward direction. So if we throw a particle from the ground in the upward direction, so this is going to be the case. Or we can also further add with this that this is thrown at t equal to 0, and this is the situation when we are studying this particle is of t equal to any time t. So that's the general situation we are talking about. First equation will be v is equal to u plus at in one dimension, so that will change into. Now we need to know how to write this v. V is pointing in the upward direction. Since it is pointing in the upward direction, so we will write it as a positive. How to write u? See, what is the direction of u? Direction of u is in the positive y direction, hence we are going to write it as a positive. Plus a. Since g is pointing downside, so acceleration in this particular example is going to be written as minus g. So that's going to be minus g into t. T will remain the same. So the first equation will turn up as v is equal to u minus gt. So that's the one equation. Now this equation you might be knowing, and the another important point that I'm going to talk about is this, that this equation will be true for the entire journey of the particle. Entire journey means whether it's going to move up. After a certain time you will find it's going to go up, then it has to return down. Even though it's returning down, the same equation will be valid. Same equation will be valid, right? So this v, if it is unknown, so if it is returning down at this location, then you'll find if you place the value of u, g and t for this particular situation, then v will be coming automatically negative. That means if v is coming negative after calculation, then we can say the particle is returning downside. So this equation that we have drawn over here, this is for the entire journey, that means including the downward motion as well, because that's a vector, so vector take care of all the directions. And let's talk about the second equation, which is we used to write as a x or r is equal to ut plus half ad square. So for this particular case, when we have thrown this from the bottom to up, so R will be the position, so we will write it as y. Y has to be written as a positive because it's the upside from the reference. And again, u is a positive, t, and a can be written as minus g, so half gt square. So that becomes your second equation. Now second equation of motion and using the first equation of motion will be sufficient to solve the entire problem. But still, if you are interested, we can draw the third equation and fourth equation. So these two equations are sufficient to describe this motion completely. How they sufficient? Let me explain. What can be asked to you? You can be asked find the velocity at any instant. If the velocity is asked at any instant, you can find the velocity at any instant t. You might be asked what is the position of the particle at any instant. So position of the particle at any instant can be found like this. So if you throw a particle from ground upside with initial velocity u, then your interest will be at what time, where the particle is, and moving with which velocity. So all the parameters can be calculated by these two equations. Making sense? So once you are able to write these equations, then you can solve. Now the challenges will be coming how better we can use these equations. In fact, we can also drive the third equation and we can use that as well. Now let's talk about some obvious examples or questions that can be framed out of it. So one of the obvious question can be if it is thrown from this position, so what is the maximum height it goes up to? Then another obvious question that can be asked, if it is thrown from this point, how much time it will take to come back to the same position, or how long it takes to go to the highest point. So these are some obvious questions, and we can make the formulas for these questions which you might be knowing from previous classes as well. So let's talk about this maximum height. What is going to be the maximum height of this particle if it is thrown as shown in this figure? So we can calculate this maximum height. What we need to learn, how we can get this maximum height. So there can be n number of ways to get this maximum height. That means first is maximum height is going to be the location of the particle when it is here. So that's going to be the maximum height of the particle from the ground. That means we need to talk about the maximum value of y. Can we say we need to maximize this y? So we can maximize this y. And we have learned the concept called maxima and minima. We can use that maxima or minima to find the value of this h value. Another way could be, because we know when the particle is at the topmost position, its velocity will be momentarily zero. Since velocity is zero, that means we can use the equation 1, we can put the velocity 0, we can find what the time is. And we can connect then. What the connection would be? Connection would be when the velocity becomes 0, at that moment height becomes maximum. So whatever the time we calculate from the first equation, we can put that time in the second equation, we can get the value of maximum height. So point is, once we have written these equations and using previous knowledge, we need to think how we can find the desired quantity in various ways. So I'm going to use that maxima and minima because that's going to be new for you. And another way you can use and try and find the value of h, see whether you are getting the same amount. Now to get this thing, we can say for y to become maximum height, what we need to say, we need to find dy upon dt and we need to place dy upon dt as 0. So let's do that. Find dy upon dt. This is expression, we can find dy upon dt. Here we need to know which terms are constant. U is a constant, g is a constant, 2 is of course a constant, t is a variable, so t is the only variable. So if you differentiate this, so first term will become u, second term will become minus half g into differentiation of t square, which will become twice t. That has to be 0. If you simplify this, you will find the t value coming out to be this 2 and 2 getting cancelled out, u by g. This in itself becomes one important result for us. This says this is the time at which the particle will be at its maximum position. So we have got to know how much the time it will take to reach to the maximum position. Now you can substitute this t back on this equation y to get the h value. Hence we can say h is going to be equal to, u into t, and t is u by z minus half z and u by z whole square. You can simplify it, so you'll find it's going to be u square upon g, then minus half of that number, so it becomes u square by 2g. So we got to know what the height is. Height is u square upon 2g. So that's again important formula, and that formula has to be remembered, because whenever it's asked about maximum height, we are not going to do this calculation again and again. We can simply use this h to get our answer. You can find the same height by using the another way, like putting the v equal to 0 at the topmost position, get the time. So we can say this t that we have calculated is the time to ascend or time to go up in the vertical motion. Now this motion is quite symmetric. We can use the symmetry, or otherwise we can claim something else. What type of the acceleration or deceleration is acting on the upside, similar acceleration is going to act on the downside. So there's going to be symmetry. Upward motion is going to be similar to the downward motion. By using that, we can say if the time of ascent is u by z, then the time for descent, that means to come down, is also going to be u by g. So we can also find what is the total time of that journey, right? So total time is going to be twice of this. So I'm writing in short that total time is going to be t is equal to 2t. So let me mark a line over here and write that point. That's called the time of flight, and that time of flight is going to be twice of the time of ascent or time of descent. So time of flight. So whenever somebody asking what is the time of flight, that means it's total time up to which the particle was in the air. So it is generally written by capital T. It can be written as twice of u by g. I'm writing directly. You can also find this another ways. There can be n ways to find this, justify this formula. How you can find that thing? Very simple. Can we say the time of descent to total time will be the time when the particle returns back to the same position? So what will be the coordinate of y? You say y has to be 0. So in order to prove this t, otherwise what you do, use the equation number 2, put the y equal to 0. As soon as you put the y equal to 0, find the value of t, the time will come out to be this. So that becomes the time when the y coordinates becomes 0. That's also called time of flight. So these are the general important points that has to be remembered. A result, you can say maximum height, time of ascent, time of descent, they are equal. Maximum height is u square by 2g, time of flight is this. And when this particle returns back to the ground, you will find the velocity is going to be same in magnitude as it was thrown, but opposite in direction. So velocity will not be equal, but speed will be equal. Velocities will be opposite to each other. So this is for vertically up motion. In the vertical motion, there can be another case that's popularly known as free fall. So let's say there's a particle or object at a certain height, and you release from that height. And let's say that height is known to us. That height is given to us as let's say capital H, and from here it is being released. So when it is being released, that means its initial velocity is 0. So that is used when a particle is being released, or starts from rest, or it simply says free fall. That means you have made it free at from a certain height, and it's going to fall down, of course. So what the path it is going to follow? It's going to follow this straight line path, one-dimensional path, and it's going to go and hit the ground. After hitting the ground, it will be bouncing back and doing other aspects of motion. So as of now, we are not interested in the motion after impact. So we are simply watching what the motion from here to here is going to be. Later on, we will be learning how this is going to behave, like how much at height it's going to bounce back, then what is going to be total displacement, distance, and other aspects. So for the time being, they are not being treated as of now, and we are simply talking about the motion kinematics part, so we will be focusing upon that part which is which deals with the motion in this one dimension before the impact. So initial velocity is 0, and now we need to describe this motion. Now what we can do, we can keep this our coordinate system y, and keeping this as a origin we can maintain this. So we can say this upside is positive, downside is negative from this origin, so we can keep this as a origin. Or we can say, if we want our calculations to be simple, easier, so it's always advisable to take the origin at the location from where the motion starts. So we can say this is our origin. That means this is going to be, this is the origin point, and you can say this is x-axis. So that's going to be reference location. So we are considering this as a origin. I'm drawing inside, but this is at the location from where the particle starts. Then after, we need to decide y direction. Now choice is ours. We can choose this as a positive direction, and then everything downside will be written as a positive, or we can choose upside as a positive direction, then everything has to be written negatively, or everything means which is downside, upside has to be written positive. So let's say this is our y-axis. So we are measuring y from this, so this is our reference location, downside we are measuring y. So whenever the particle is at this location, so we will say this is the y displacement of the particle, this is moving with velocity v. So our this direction is being measured as a positive y. We need to make sure that we are deciding which direction we are considering positive. So by considering this positive, we can write all the equations. Now you see, when the particle comes at this location, so this y displacement is downside, hence y will be positive. V is downside, so v will be positive. Moreover, acceleration due to gravity is always downside, so this is also going to be written as a positive. So in this case, in this particular sign arrangement, you will find a has to be written as a z, positive z, and u is a 0. So equations will become, the first equation will be v is equal to u plus 80, u plus 80. Now u is a 0, so you can convert this equation like this, v is equal to gt. So this becomes the first equation in case of free fall. That means at any instant of time, how much the speed it is going to gain, it's going to be g into the time. Similarly, we can go for the second equation, which is r is equal to ut plus half at square. Now r, which is a displacement, it has to be written as a positive, and u is a 0, a has been stated, so it's going to be y is equal to 0 plus half at square, which is half gt square. So that will become the equation for the displacement. So this we can call as a second equation. And using these two equations, we can solve this entire motion. That means we can find how long it will take to cover this h height or depth, you can call, and at what time where it is going to be located. So at what time where it is going to be located, that will be given by this equation number 2. At what time, what the velocity it carries, will be given by equation number 1. Making sense? Let's say if we are interested in finding the time it will hit the ground, so how we can find that time? So for example, we are interested of time to reach the ground. So how we are going to use this time to reach the ground? Now what we need to focus upon maximum is once we know these equations will be known by all the students. Where the difference is going to come in, difference will be how better we can apply these equations to find our answer. So here you need to put your own brain. That means what is given to us, how we can relate these equations to reach this particular point, or the question that is being asked. Here it's a simple, you can catch there are going to be 1 or 2 ways only. Later on you'll find there are going to be n number of ways to find the desired answer out of given information. So we will try to find using all of these options available. Anyway, in this case, find time to reach the ground. That means we are interested when the object reaches here. So we can think of that it starts at equal to 0. And let's say that's the some time capital T that we are interested in. So if we are interested in this capital T, what we can do? We can say it's going to be what is given to us, h. So that means at t time the displacement is known to us. So we can say at when t becomes capital T, y definitely becomes capital H. So in the equation number 2, use the equation number 2, substitute these values, so you'll get h is equal to half gt square. So from here you will get the expression for t. So what that t is going to come in? T is coming as under root twice h by g. Now that becomes your formula. So whenever any object is falling freely from a certain height, how long it will take to hit the ground, you can use this formula directly. That's square root of, this square root goes up to downside. So this is square root of 2h by g. 2h by g. It's a complete square root, okay? So h is given to, once h is given to us, we can find the value of g anytime. Moreover, we can also find out if somebody asking what the velocity it is going to catch when it hits the ground. So for that saying, what we need to do? We need to use the equation number 1. So use equation number 1. If you use equation number 1, v will be equal to g into t. And what is the time? Time is capital T, which we have already calculated. So our answer will become the velocity at that instant of hitting is going to be g under root twice h by g, which you can simplify, then 1g getting cancelled out. So velocity when it hits the ground is twice gh. So there are going to be small formulas which is going to be very, very important in future, because we will be using them directly. We are not going to solve these equations. So these are the result for the case when the particle is under free fall motion. Now there can be a third category that instead of saying free fall, it says particle is being thrown downside with any velocity u. So if this u is given to us, we are going to put the u value over here. Instead of 0, we will take as a u. And our this sign convention, which is positive downside, which will treat this u as a positive. So treat the u as a positive, so this will become one equation, this will remain the second equation. Here you place y, here you place g, that's all. And you can solve then by using the same logic that we have just talked about, right? So that's a third case you can think of. And we have talked about this free fall case and the motion in the upward direction. Making sense? So this is how the vertical motion can be covered. So let's consider one example on this vertical motion. And it says a particle A is dropped from a building of height h. Another particle B is projected up with a speed v is equal to under root 2 gh simultaneously from the bottom of the same building. When and where they are going to meet? So here we are using two particles instead of one particles. Well, it's okay. So we can be studying both the particles separately, and then we'll be combining the result to find the final answer. So let's say we got two particles. This is a particle A, this is a particle B, and they are at a gap or height h. So that's being dropped from a height h. So that's its initial velocity is going to be 0, and in future, and it has been given initial velocity in the upward direction, that's u. And that's basically this v, and we can call this as a v, or we can call it as a v naught, so that it becomes the initial velocity. And then future, you know what the future is going to go. This is going to come downside, this will go upside, and they might meet at this particular location. So let's say they are meeting, and this is a scenario initially that has been drawn was t equal to 0, and let's say when they meet, that's the t time. So we are considering after t time they are meeting, and they are meeting, let's say this displacement we are measuring as a y. So we can work in either way. So first of all, let's decide coordinate system. So let's we say this is our origin for all these calculations, and this is positive direction of y. And let's say consider from the downside at a displacement of this B particle. When B particle undergoes this Y displacement, the two particles meet together. Of course, if this is turning this Y up, so we can find what this is going to turn downside. So can we say this is going to turn downside by an amount called H minus Y? And we can apply these equations for both the particles separately. So let's solve for this. You can give answer very quickly as well. And here I'm trying to apply the rules that we have learned. Apart from this thing, there is a G downside which is always acting. So our positive direction is upside. Based on this, for all the particles, no matter which particle we are talking about, A will be equal to minus C, because A is the direction of A is decided by the coordinates that we choose. Now talk about for particle B, which we are throwing from the bottom. Can we say here the second equation is going to be appropriate? So how much the displacement it is causing? So displacement caused by the second particle is y in the upward direction, that's why positive. Initial velocity is v naught, which is positive, into t, and then acceleration is going to be negative, that's why we are going to write minus half gt square. So that's one equation for the particle number B. We can make the equation for the particle A. If we make the equation for the particle A and use the same equation, displacement and time, that's the second equation. So you'll find its a displacement is downside. So it's going to be written as a negative. So we are going to write it as a minus h minus y. Be careful what I'm writing. And this is the sign convention we are following. And its initial velocity was 0, so we are going to write 0. A is a negative, so we are going to write minus half gt square. Is it making sense? So that's going to be equation number 2. What we can do, we can multiply both sides with minus sign, so we can write this as, or rewrite it as, h minus y is equal to half gt square. So that will become equation number 2. Once you got to know equation number 1 and equation number 2, then we can say there are two equations, there are two unknown. One unknown is y, another unknown is t. And mathematics says if the number of unknowns and number of equations are identical, we can find it. We can solve those equations. So when, that means time, where, that means y, we need to find out. So let's simplify this. For simplifying, what we can do is this: we can add the equation 1 and 2. So equation 1 and 2, we need to handle it. If you add equation 1 and 2 together, you will be finding some sort of this. This y will get cancelled out. So first thing we are adding. So y is getting cancelled out, so it's becoming h is equal to, and you will find this half gt square is also cancelling out. It's simply v naught into t. So from here the t has been calculated. It's h upon v naught. By the way, v naught has been given to us, so we can put the value of v naught, so it becomes h upon under root twice gh, which will ultimately lead to under root h by 2g. So this becomes the time after which they are going to meet. Making sense? And then we need to find what the position or where they are going to meet. So you can put the value of t in either of this, either in the first equation or in the second equation. From there we can find the value of y. So let's say we are using the first equation to find the value of y. So this is going to be v naught, which is under root 2gh, or we can say v naught into t. V naught into t is basically h. So we can use that directly. So it's going to be basically h minus half gt square. It's a half gt square, which is going to be h upon twice g. Again you will find g and g getting cancelled out. Is basically h minus h by 4, which is basically 3h by 4. So from here we are able to calculate the value of y, that means displacement from the bottom or that from the ground is a 3h by 4. So we can claim the two particles are going to meet at a height from the ground 3h by 4. So this is going to be 3h by 4. If it come out to be 3h by 4, total is h, so you will find this is going to be h by 4. So if we got to know where the particles are going to meet together and at what time they are going to meet together, so both answers are clear. Now the important point that you need to focus upon, writing this vector equation. These are vector equations, so they carry their magnitude as well as direction. Direction has to be taken care of. Fine. Here is another question, and this is homework for you. Based on this vertical motion under gravity, and it's read a person is sitting on the building and dropping the balls in a regular interval of time, 1 second. We need to find the position of third ball when the sixth ball is being dropped. So you solve and give the answer in the comment section, and if you can find answer, so that's going to be indicating that you have understood the basic aspect of it. And in the next video we will be talking about two-dimensional motion of under the gravity, that's called projectile motion, quite important for us. So in this video we talked about motion under gravity. Make your notes, and if there is any doubt you can ask. Thank you for watching.